One tiny insect can build something enormous, a towering structure rising from the earth like a natural skyscraper in the wild. There is no blueprint, no architect, and no master plan guiding the process, yet construction continues without pause. Inside this structure lies a hidden world of tunnels and chambers, carefully formed without centralized planning or conscious design.
While conditions outside change dramatically through heat and cold, the interior remains stable, balanced, and remarkably well controlled.
Today, scientists and architects study structures like this, searching for clues to one of nature's greatest engineering achievements. This is a termite, a tiny insect most people overlook, yet one capable of helping build extraordinary structures. Alone, each one seems insignificant, but together they form vast colonies, working like parts of a single living system. Each termite has a specific role. Workers build, soldiers defend, and the queen sustains the colony through reproduction.
There is no leader issuing commands, yet the colony functions with impressive coordination, precision, and efficiency every moment.
From simple interactions, complex organization appears, creating behavior that feels intelligent despite the absence of any central mind. This phenomenon is known as swarm intelligence, where many individuals follow simple rules. Yet together each termite performs a small task, carrying tiny particles of soil, while responding only to what happens in its immediate surroundings.
They do not understand the entire structure, only the conditions around them, yet their responses create an organized and functional system.
They communicate through chemical signals called pheromones, invisible trails that guide movement and influence the behavior of nearby termites.
Over time, these small individual actions combine, gradually forming massive structures that no single termite could ever plan alone. Termites build using soil, saliva, and organic matter, creating a natural material that becomes stronger as it dries over time.
This material hardens into a solid structure, strong enough to withstand heat, wind, rain, and the harsh conditions of the savanna.
Each grain is placed carefully, one by one, gradually forming walls and foundations that support the entire structure above.
This process repeats millions of times, slowly expanding the mound, while strengthening its structure as the colony continues to grow.
Over time, tunnels and chambers emerge, forming a complex internal architecture designed to support airflow.
Some termite mounds rise several meters high, forming massive structures that function as both shelter and a complex living system.
For termites, this structure is not just a shelter, but an entire world designed to support life and stability.
But the most remarkable feature of this structure is hidden deep inside the mound, beyond what we can see from the outside.
Within these tunnels, air begins to move naturally, flowing through the structure without any mechanical system or external control.
Inside, the temperature remains stable, creating a controlled environment that allows the colony to survive under changing conditions.
Even when the outside environment becomes extremely hot or cold, the interior conditions remain balanced and consistent.
A network of interconnected tunnels allows air to move through the entire mound, linking every part of the structure. Warm air rises through vertical shafts, moving upward through the structure and eventually exiting near the top of the mound. At the same time, cooler air is drawn into the mound through lower openings, replacing the rising warm air. This continuous airflow cycle creates a natural ventilation system, keeping the internal environment stable and highly efficient. Unlike human systems, this process requires no electricity, no machinery, and no external energy to function continuously and effectively. Despite its simplicity, this natural system operates with remarkable efficiency, maintaining stable conditions through a purely passive design. Inside the mound exists an entire ecosystem, carefully maintained to support the colony and its complex internal processes. Within specialized chambers, termites cultivate fungus, using it as a primary food source to sustain the entire colony. This fungus depends on stable temperature and humidity, making the mound's climate system essential for its survival and growth. If this balance is disrupted, the entire system can fail, revealing how deeply interconnected every part of the mound truly is. Scientists and architects have studied these natural systems, searching for ways to apply similar principles to human design. By studying termite ventilation, Modern buildings can reduce energy use while maintaining comfortable indoor temperatures naturally.
One well-known example is a building inspired by termite mounds, designed to regulate temperature using natural airflow systems.
It uses passive airflow instead of traditional air conditioning, allowing the building to remain cool even in hot climates. As a result, the structure consumes far less energy compared to conventional buildings designed for similar environmental conditions. This approach saves significant energy costs, demonstrating that nature often provides the most efficient solutions to complex problems. A tiny insect, often ignored and underestimated, capable of building systems far more advanced than we might expect. Through cooperation and simple rules, termites create massive structures that rival human engineering in surprising and powerful ways.
Perhaps the greatest engineer is not human at all, but nature itself, shaping solutions over millions of years.